Welcome, everyone. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects. And I've been working as an architect now for over 25 years, and I've loved every last minute of it. There are times where we just have to come out and really talk. See, when you're talking about mission critical or high availability systems, you're talking about life and death situations in many cases. For example, let's take a hospital. I've been designing systems for hospitals for decades. What would happen if the hospitals were attached to the cloud, all their critical systems were on the cloud, and then the cloud went away? Or you wanted to dial 911 or 999 in the UK for emergency services. And when you did, they just weren't there. Well, this is what happens when you use a single cloud. People can die and will die if you're not careful. So I want to talk to you about a few things. We're going to talk about multi-cloud architecture. We're going to talk about high availability cloud architectures. We're going to talk about what is a hybrid cloud. Maybe we'll talk about the OpenStack cloud or the Nutanix cloud. We'll talk about what is multi-cloud and why you have to be multi-cloud. And we'll talk about the concept of a hybrid cloud or a multi-cloud, because if you're in cloud computing, this is critical career training. And if you're a cloud architect, multi-cloud architecture is our world. So let's just talk a little bit about high availability, and then we'll talk a little bit about communications and communication transparency, and then we'll talk about trust. And then if you guys want, I will do it live, and I will build a live multi-cloud architecture for you with you guys, where we can talk about high availability and lack of single points of failure. I've done it before, and I'll do it again. So I want you guys all getting cloud higher, but more importantly, I want you guys to be the world's best cloud architects. So when you go on a cloud architect interview, get a cloud architect job. But I also want you cloud architects to know that you're going to design systems that are going to work. You're going to design systems that are going to please your customers. You're going to design systems that are going to save lives, and you're going to design systems that will make the world a better place. And all of that starts with a lack of a single point of failure. So, when we design systems, and that's really why I want to talk about communication and collaboration, there are no single points of failure. So let's first look at the reality of life. Let's assume we have a data center, a high availability data center, the kind I've been designing for 25 years, the kind Amazon has theoretically, the kind Google has theoretically, the kind Azure has theoretically. There are no single points of failure. So if you connect to the internet, you don't just connect to AT&T, you connect to AT&T, Verizon, and NTT. Because 1 is none, 2 is 1, and 3 is greater than 2. Now, you could say, why don't we have 2 AT&T connections to the internet? Because if cable 1 is cut, cable 2 will still work. And in our minds, that just pleases us, and it feels good, great. 2 internet connections from AT&T. Until AT&T has an outage, or AT&T has a BGP problem, or AT&T has an RSVP signaling problem, or AT&T has an issue with one of their MPLS-T tunnels, or their IGP, and AT&T is gone. So we never be crazy enough to do 2 connections to the internet with the same internet service provider, 2 connections between our New York and our San Francisco offices in a single cloud provider. Why? Or a single network provider? A single network provider is a single point of failure. The first cloud I worked on was in 1997. It was called Frame Relay. We would never get 2 frame relay circuits from the same cloud provider. It was insanity. Cisco advised against this, and we'll talk why we did this. But Cisco would never let you do that. Neither would Juniper Networks, Versa Networks, or any really reliable networking company. So, we would have never done that because we knew better. And you go to a bank, you go to a hospital, they know better than this. But the cloud providers and their certifications are saying, hey, 2 availability zones, and you have 99.99% availability, and 2 regions, 2 availability zones, 99.999, 5 minutes of downtime per year. And this sounds really great, right? Until the cloud's hacked, or until there's a network problem that takes the cloud down, or until the control plane of the cloud goes down. And that's what we're seeing. We're seeing these big and massive failures with the cloud providers. Now, today's failure was not so bad with AWS, but the point is we are dealing with four major outages in a very short period of time, and that is not including today. 4 major outages. Azure had an outage on October 13th, and it was a massive outage. The Google Cloud had a massive outage on November 16th. On December 7th, the AWS outage hit multiple availability zones, multiple regions, bypassing everything they all told us was their high availability structure. And you know what? On December 15th, they had another multiple availability zone, multiple region catastrophic failure. So that's 4 of them. And now AWS has another failure today. And AWS tells us we have a power problem. Now, this is really interesting. It could be a power problem, and we're going to have to trust AWS. But when you design a data center, you have 2 power companies coming in whenever possible. And you have 2 power transformers that come in whenever possible. And you have 2 sets of UPS batteries. And you have 2 sets of generators. So it's pretty almost impossible to have a data center that has a power failure like what we're dealing with AWS today. In 25 years, unless we had a hurricane and the generators ran out of diesel, I have never seen a data center power outage before. Which gets us back to communication and honesty and integrity. Do you know what I've also not seen in 25 years? I've never seen an impaired network device. Like one network device and another network device went to a bar and got drunk and decided to be impaired. So when we're dealing with high availability and high performance, we need our customers to trust us. And how do we trust our customers? We give them honest, open answers. So abusification, for example, or making things hard to understand is not there. So I really would love some of the cloud providers to really tell us what's going on so we architects can architect around it. Who knows what happens, but I can tell you one thing. Lots of companies are not entertained by answers like impaired networking devices or power failures because these companies would not have a power failure in their data center. They have backup generators, they have backup UPSs, and they have backup batteries. And they've spent 20 plus years learning how to not have these single points of failure. And now we're going to the cloud. And I love the cloud. I mean, I truly love the cloud. I think the cloud is the greatest thing in the world. A virtual network in a data center with speed, agility, and performance, and almost unlimited scalability. Wow, that's great. And to me, that cloud is just the next evolution of the virtualized network in the data center. So it's super exciting. So let's talk about these high availability architectures. Let's go back to the hospital. I did consulting for hospitals all over the world. If you put this hospital in a single cloud, 2 availability zones, and we had any one of these outages that Azure or Google or AWS had in the last month, the hospital will be down. Now, here's what it's like. I used to practice medicine. Here's what it's like being in a hospital. In the old days, when I practiced medicine, it was great. I had these paper charts with scribble notes all over them. And you know what happened? If the power went out, we took our flashlights out, we looked at the paper charts, and we said, okay, this patient is allergic to azithromycin. Don't prescribe macrolides, prescribe quinolones. Life is good. Then, about 20 years ago, a major hospital in Massachusetts, had a major outage. Now, this hospital, interestingly enough, was one of the first hospitals to digitize and go from paper records to electronic records. And when the network went down, you know what happened? No one knew how to practice medicine. All the young people in this hospital in Boston were stuck. They all knew how to use the computer. They actually had to bring in old retired doctors that were no longer working, that would know how to go to the hospital and figure out how to work without decision support systems. So when we're dealing with these things, criticality matters. I paid my way through college by working as a paramedic. People would dial emergency services. When you call 911 on your phone, you expect an operator to say, how can I help you today? Is this police, fire, or medical? If we're in a single cloud, guess what? The cloud goes down because of the hacking event, a network event, or a control plane failure. Our people are dying. Someone will die. So, those are mission critical systems. What about a military base, for example? Mission critical. Now, let's get out of the world where people are dying and into the world where people can be losing millions of dollars a minute. Let's take a bank with an algorithmic trading program that may have bought $50 million of a stock to trade that wants to sell it and can't because their systems are down. Huge expenses. So now you start looking at things of the problems of what can go wrong. If somebody can't get to Netflix for 30 minutes to watch their favorite show, nobody dies. That's fine on a single cloud provider. If you can't send a Slack message about something at work, like today that happened because Slack was down, nobody dies. If you can't get to Hulu, like one of these cloud issues, nobody dies. You can use a single cloud with multiple availability zones for that. But now take a hospital, a healthcare delivery system, things that matter. Someone will die. We can't use these single vendor, high risk solutions. We need something better. And if you look at the medical grade network, if you find it on the internet, which is a document I wrote 10 years ago, it was public facing documentation for Cisco. I traveled hundreds of thousands of miles that year. helping people learn, hospitals build it. It was all around the frame of how do you design a system that can't go down, because if it goes down, people will die. So for all you cloud architects, I want you to always think about no single points of failure. No single points of failure. So you know what we'll do? We'll map it out real quick. I'll show you how you build a high availability, high security environment, because every cloud architect should know this. Now, the cloud architects in our Cloud Architect Career Development Program have always designed, always, 100% of the time, that everything they're doing is multi-cloud. Why? Because we've never always thought it was acceptable to use a single cloud. And we've said it forever, but the cloud providers were saying, you can do it, you can do it. Now the customers know. It was about a year ago, about 29% of the customers were on a single cloud, which made people like me nuts. Now it's approximately 3%. Now, in certifications, are going to say, oh, 2 availability zones, 4 nines. Well, you know what? Do you know how many cloud providers were 4 nines this year? None. None of the biggies. With multiple availability zones. So they can't do it. Now, it's not saying these cloud providers aren't good. Let you understand this. They have the best technology in the world. They also have the best engineers in the world, and they have the best architects in the world. So they are not amateurs. This is not amateur hour, but things fail. There'll be routing protocol issues or bugs that occur. There'll be a service provider that has cable cuts that'll occur. You'll run into a software bug on a device that'll occur. Things happen. There's a hacking event that occurs. Much more common than you think. And I have no idea what happened here, but a hacking event is probably a lot more likely than a power failure in a data center. Now, we have no idea what happened here, and we're never going to know, because saying we had power failures and the power failures are over, but we still have problems with X, Y, and Z, probably doesn't make most architects feel comfortable. It doesn't make them feel like their answer questions are answered, but we don't know. But let's talk about architecture. In order to design something, you have to understand how it works. You have to understand its strengths and its weaknesses, where are your opportunities for improvement, how does it work, how do you put the pieces and parts together, and how do you design something that benefits your customer? For that, you need information you can trust. Now, if a cloud provider says to you, we made a BGP misconfiguration error that caused us to be transit for half of the internet, as an architect, I understand that. As an architect, I know it, and I'm like, okay, I get it. You had a problem, you fixed it, I understand. But an impaired network device, I can't architect around that, because there is no such thing as an impaired network device. It just means it's a network device that doesn't work right. So, okay, a patient dies. Why did they die? Did they die of a heart attack, a stroke, diabetes, COVID, jumped off of a building, shot themselves in the head? I don't know. But that's about as descriptive as, an impaired network device. So communication matters for everything. And for we architects, communication is essential. Communication from, what do you want, Mr. Customer or Mrs. Customer? What are your business goals? What are your pain points? What are your challenges? What do your current systems look like? What problems are you having? We need information. Good information leads to good architectures. I tell my students, when you're designing an architecture, they say, what do I need to learn most? What's the one most critical thing that I have? And I say, communication. I said, and they're like, communication, what about technical? I said, if you can't ask the right questions, you don't know what your customer wants. If you don't know what your customer wants and needs, you don't know what to design. You can't do anything without communication. So in your career as a cloud architect, what's going to carry you is people are going to count on you whether they can understand you. Can they communicate with you? Can they trust you? If I told somebody we had a system that was down, and we were partially down this morning from Amazon because our cloud provider was not using 2 clouds. We use a cloud provider to host our things, and they are all on AWS. We were down. Now, I'm probably going to stop using my cloud provider and build I actually have an OpenStack cloud here, and maybe I'll use AWS or probably Azure and my own cloud to do it, because you can see we keep going down because people don't understand a single cloud is a single point of failure. Single network, single point of failure, single cloud, single point of failure. So let's have some fun with some PowerPoint. Let's really talk about how do you design high performance, high availability systems that don't have single points of failure. And while we're at it, we'll show you why certain things are or aren't likely to occur. So let's look at your traditional environment. Now, I've got to tell you this. I've done the same architecture now for 25 years. The only thing difference is instead of using a virtual data center in the far end. I've used a regular data center. And for any of you guys that have not been in cloud computing forever, we people that have been in cloud computing forever realize it's just a network in a data center with a control plane. So let's think about what this actually is. Let's kind of look at them. So let's say you've got a data center. Here's your data center. And how do you make this high availability? I'm going to show you right now. Here's our data center. So what do we do in our data centers? We got this. We've got 2 sets of power coming in.
Mike.
Yes.
We can't see.
Ah, well, thank you for that. Thank you for that. So can you see it now, Chris? So let's take this environment. Let's say this is your power coming into your organization. All mission critical data centers, all of them. And I'm sure Amazon do too, because we've done this for 30 years and Amazon is highly, highly sophisticated. They typically have 2 power sources coming in. Now, power doesn't come in at the right voltage that we use. It comes in, and it could be 2 or single phase or 3-phase electric. So now what do we have? We've got 2 sets of transformers here typically. We've got multiple transformers. Now, after we have multiple transformers that are taking us from 1 voltage to something that we use, we typically have some kind of a power environment. We're typically going to have our power bank. And let's just say we have 2 generators here. We're going to have a generator 1 as a backup generator. Now we're also going to have a generator 2. And this is for our power. And of course, we're probably also going to have a backup battery system, like a giant UPS system. And the reason we use these battery power packs is twofold. One, if we run out of fuel in our generators and the power systems are going down. But also, the generators aren't as smooth with voltage regulation, and we're dealing with sensitive electronics. So we typically do this. We typically use multiple transformers, multiple generators, multiple sources of power coming in, and multiple batteries to clean the power and condition the power before it goes to our users. So that's why when you do this, unless you get a hurricane and an earthquake and you run out of fuel after a week, it's pretty rare to have a data center that loses power. Now, there's a couple kind of power switches in data centers can go wrong, but I realize it's really rare. Now, could you hack into the power control system of a data center and knock it out? Absolutely. But it's pretty rare for all these things to going on. But we're going to trust that Amazon, we're going to believe them today. We're going to believe that their power sources coming in failed, their backup generators failed, their backup batteries failed, and everything they have, it all failed, and they miraculously had a power failure in a data center and it's down. So let's assume we're going to believe that because we have to believe them. We have no choice. Now, right now, this still isn't high availability. So let's say we showed you how you make the data center power. Now, let's talk about the data center. What happens if you have a single air conditioning unit and it fails? Your data center becomes 9,000 degrees, your equipment melts and it shuts itself down and everything's gone. So you've got backup air conditioners too. So there's nothing here that's a single point of failure. Nothing, nothing, nothing. So typically speaking, you'll almost never see that. But then again, you'll almost never see an impaired networking device either. But you know what happens. So just keep that in mind. But let's say this is your data center. Now, if you have a data center at your customer site, you're pretty good. You can build a high availability 4 nines data center easily. Multiple power, multiple network connections, redundant switches, redundant cables, redundant fiber optic cables, redundancy everywhere. Now, you can't build a 5 nines data center, but you can build a 4 nines data center. So you could build data center that's 4 nines, data center that's 4 nines, connect them together, and that's your 5 nines network. But we're going to go cloud. Now, a single data center in the cloud, they claim can do 3 nines availability or 99.9%. Why is the cloud's data center less reliable than your own data center? Well, let's think about the cloud. In your own data center, it's one customer. In most cases, it's just your systems, your VMware clusters, and your storage. Now we move to a cloud, and I don't care whether it's a Nutanix cloud, which I love. By the way, Nutanix cloud is amazing. An OpenStack cloud, which I love, it's amazing. Or the AWS cloud. Once you start installing all these control planes of the cloud, and you've got the control plane of the cloud and your orchestration, and now you're managing thousands of customers, Of course, AWS can't deliver on a shared medium as good as you can do in your data center. Neither can Azure, and neither can Google. And these are the world's best network operators. Don't think for a second they're not amazing. These are the most qualified people in the world. You will find network engineers that are being paid $500,000 at these companies because they're that good. But stuff breaks, and that's why we never architect around a single point of failure. So kind of keep that in mind. So let's assuming we're dealing with ultra high availability here. What could we do here if we want extreme availability? And this is the kind of systems that I design, the kind of organizations that ask me to design things. They want to know that if the power fails, the network fails, or anything fails, they're still up. So how do we do it? So let's say this is going to be AWS, and I love AWS, and I might be joking a little bit about their abusification of terminologies when they try and call things, but their technology platforms are great. So let's say we're dealing with AWS here. I'm just a fan of honest, and I'm just a fan of easy to use communication. Okay, so we've got this AWS, and while we're at it, let's put Azure here. Two great clouds that I love. Could be the Google Cloud too. I love that one too. It doesn't matter. Now, let's think about the networking that has to occur. Now, if you deal with AWS, they say, hey, you get a direct connection or a VPN connection to us, and it's high availability because it's a logical device on their end. So I want you to really think about that logic that they teach you in the Certified Solution Architect Professional. Here you've got one router, R1. Now on the cloud, you've got this virtual router. It's a fake router. It's an R1, and now it's in what's called in one availability zone. Now we've got virtual router R2. And if you deal with what AWS is telling you, they're saying, look, you got this high availability thing here because you're connecting it, and we automatically create two virtual things to you to go to two data centers. Okay, while I'm typing this out, does anybody see the problem with this not having high availability connections? Can anybody type it in the chat box, the major problem we have, why this is not high availability, why there is a major single point of failure here? Because we have a major single point of failure in this, even though AWS tells us it's okay. It's a very major single point of failure. You don't know, or you don't type it in the chat box, I'm going to tell you right now. Leo, exactly. So while AWS tells you this is a good architecture, and they don't recommend any kind of special routers, you got one router over here connecting to two at AWS. So if this router dies, you're done. It's dead. So that's the theory of one single connection, we're done. And we're only talking about the single cloud provider. But just that doesn't work. Just that guidance that you'll hear in your certification is anti-high availability. It's introducing single points of failure. So now how do we make this better? We've got two really good options here. Option one, which is the cheaper of the options on a monthly operational expense perspective, is we take router one and we make router one high availability, this router over here. How do we do it? We put two power supplies on it. So we plug it into two different circuits across our data center so that if a power source to the data center and the generator and a transformer were to blow up and a PDU were to go wrong, don't worry, the switch is plugged into another circuit. But we can't do that with the kind of routers they teach us in the Certified Solution Architect Professional training. That's why this is high availability versus that. So no. And then what happens? A router has a brain, a control module. You know what happens if that crashes? The router's down. So we're going to put a second control module in here. Now on these links, if we put all of our ports, our links on a single card and the card fails again, we're down. So we're going to use multiple cards. So that's one way to do it. Or better yet, here's how you create your high availability connections to the cloud. You get one direct connection from one cloud provider to the other. You get another direct connection because this is what you're going to do when it really matters. And heck, if you want it, you're going to get a backup VPN over the internet. But let's talk about how to make that backup VPN. So this is how I would design my connections to AWS for a high availability environment. Now, on Azure, I would do the same thing. I would use two availability zones. And the reason I would use two availability zones is 1 is none, 2 is 1, and 3 is greater than 2. And I'm not picking on AWS here. I would do the same thing on Google, same thing on Azure. It's all the same. So now, what would I do? I would create 2 high availability connections. I put one high availability connection here, and I'd put another high availability connection here. And here's what I would do. I would connect them to the to the virtual routers that are on the, what do you call it? So Azure calls it Express Connect. The rest of us call it a private line from the networking. I don't really call what you call it. Basically, you need a private line. So we've got R1, R2. So let's see what this looks like. R2. Oops, 2. We'll take this as router 2 again, R2. So now, of course, we'll get these direct connections, and we'll spread our direct connections across multiple routers. If we want to load share, we'll load share via BGP policy, where maybe we'll send one subnet on one link and another subnet on another link. So that's basically what our connectivity is going to look like. Now, I want you to know this. This link over here could be on AT&T or Verizon or NTT or CenturyLink. This backup link will not be on the same provider, meaning we're not going to connect with a second AT&T link. We can't connect on a second AT&T link, and here's why. If AT&T goes down, we lose connectivity to the cloud. So what we really should do here, if we're really smart, is we should have a cloud. We should have a link on 2 different service providers across 2 different routers, and the router should be connected to multiple power sources, et cetera, et cetera. You see there's redundancy in your redundancy inside of your redundancies. There's no single points of failure. Now that we're done that, which is really critical, we still should have some VPN backup. So single internet connection equals single point of failure. So let's say for right now, let's say these links are on Verizon and AT&T. Well, when we connect to the internet, maybe we use a different internet service provider, something a little better. So let's think about what that could be like. So let's think about, I'm trying to look for my pretty cloud shape, and I am definitely not Mr. PowerPoint here. So let's just say this is our internet provider. If we want really good internet service, what would we do? Instead of connecting to one internet provider, well, maybe we'll connect to 4 internet providers. Internet provider, internet provider, internet provider. Now, if we've got 4 connections to the internet, and we want to load share across these internet connections, we're still going to need a couple of routers, and we're going to have to run BGP to exchange full routing information to the internet. And why is it good to have multiple connections? Okay, so let's say this connection is AT&T, this connection is Verizon, this connection is NTT, and this connection is CenturyLink. Well, the people that are attached to CenturyLink will be 1 hop away. The people that are attached to AT&T will be 1 hop away. The people that are attached to Verizon as their internet service provider will be 1 hop away. And the people that are attached to CenturyLink, NTT, whoever we forgot, AT&T, I don't remember, they'll be 1 hop away. So now we get to load share across 4 internet service providers, and we get the best routing. So now we've got the combination of speed, performance, and routers. And we've got 4 internet connections. So if 1 internet connection goes down, we don't care. 2 internet connections goes down, we don't care. 3 internet connections go down, we don't care. So see, this is why it's high availability. Now, if we've got 4 connections to the internet, and we have high performance routing because of BGP with the internet, now our VPNs are going to perform a lot closer to a private line or a direct connection because we've got optimized routing. So now how do we make it better? So let's take our routers. Now let's create a VPN backup, but we're going to leverage those 4 internet connections to create our VPN backup. So this will be our R3 for VPN. We'll put a V next to it. And this is going to go to another virtual router that's sitting at your cloud provider. We'll call it R3. Now we've got another VPN. See, what you're seeing is link, 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 which gets us back to our favorite military outage. 1 is none, 2 is 1, and 3 is greater than 2. If you're going to send a soldier to the battlefield, give them more than what you think they need, because trust me, they'll find out once they get there that they're going to need more than they need. When you're running a 911 system, and trust me, I spent 7 years as a paramedic, and that's how I paid my way through the university. If those systems go down, guess what? People die. People die. So we can't take this high availability thing lightly. This high availability thing is really critical. And when outages occur, we need to know why. And why do we need to know why? We are architects. What do we architects do? We design around constraints. We design around single points of failure. We design around problems. We are not configuring things all day. We are trying to figure out how to optimize things and fix things and improve our customers and our clients' worlds, their lives. And we can't do that if we don't know how things work or why they work. So that's why I wanted to come talk to you today, because we're going to see lots and lots of these cloud things. And I don't really know what's going on with some of these. I don't know if the cloud providers were hacked, hypothetically speaking. Maybe they were, maybe they weren't. Maybe they were and don't even know it. Maybe they weren't. We don't know. But it's good to know, to have some degree of honest transparency. It's good to know when you've got a BGP issue versus an RSVP signaling issue, because then you as the customer can plan around it. So communicate honestly, openly, and ethically with your customers. If your customers ask you what happened with AWS and you're lucky enough to find it, make sure you're open and transparent with your customers if you know. But don't hypothesize, don't make things up, don't gossip. Now, here's the thing. When a cloud provider is going to give us abusified information as deemed to be made cryptic intentionally so we can't figure it out, it causes this. It causes people to guess. It causes people to hypothesize. So in your cloud architect career, in your multi-cloud architect career, if you mess something up, be open, be honest, have good integrity. Tell your customer exactly the mistake. Tell them what happened and how you fixed it and how you'll know it'll never happen again. I don't know about anybody else. I don't feel secure that a cloud provider knows how to manage their power after today. Now, I do feel secure they know how to manage their power, but if that's all I heard for the first time, I'd be worried. If I saw 3 outages in 2 weeks and there was no explanation to the outages other than networking devices were impaired, or, for example, we had power problems, it doesn't feel transparent to me, and it doesn't feel transparent to the customers. Do you know how many people called me today and asked me what I thought? Whether they be media outlets that I spoke to today or customers all over the world that I spoke to today, I received no less than 50 phone calls from experts in the industry. Mike, what do you think happened here? And I said, I have no idea. And they said, the reason I have no idea is it's very rare to have that kind of power failures. It's also very rare to have an impaired network device. So I don't really know what's occurred. All I can say is it's a great cloud. They've been around for a long time. They've got highly, highly, highly sophisticated people there. People that are not going to architect around single point, that are not going to leave major single points of failure. So this is the concept. So realistically speaking, that's what I wanted to come tell you all. I want you to all think about what's in the best interest for your customer. It'll never be single cloud. Let's talk about the other reason single cloud is not good. We just talked about high availability. Let's alternate some way. So let's say we went to a single cloud and we used all these cloud native services and we went serverless. And the cloud was like a cable company. After a year, they decided to raise our rates 40%. Guess what? We're stuck. We can't get off. We're now serverless. We have to spend a fortune to get off. Now, if we used open standards and we had nice open standards, and instead of using DynamoDB, we used MongoDB, and we run MongoDB across 2 clouds in our data center, everything's working perfectly. Now, instead of using some other silly vendor proprietary service, we use another open service, like an Oracle database. Now, Oracle database goes in our data center, and it works perfectly in Azure and Google. And we put it directly on a virtual machine, so we don't have to deal with the cloud provider's limited versions. We're building it all. Now we're outsourcing to these data centers. We've got 3 data centers, and everything's going to work great. High availability, high performance. And you know what? How do we make it work? We don't use regular firewalls. Not at all. We use something from the marketplace. We use things to make it really big, really secure, and really, really, really powerful. So what you'll see is it'll work anywhere. You know what? Let me show you one more thing. Let me show you how we design security architectures. And I'll show you how it doesn't matter which cloud provider you're on, you can do the same thing and how you can make them interoperable. So let me try and share this one architecture with you, and I'll walk you through a security architecture, and then I think we'll call it the end of the day, but I want to show you how you have multi-cloud with security, performance, and actually, no, maybe it's a little bit too much to get into deep security architectures, but I'll show you a little bit of it. So imagine this. If you're with AWS, for example, you've got WAF, which is good. Do you think Google's cloud firewall is different than AWS's cloud firewall? Yeah. You think you can have an identical policy and the identical security policy? No, because you're dealing with services that are almost equivalent. Now, let's say we decided to go to the marketplace and we took a Palo Alto firewall and we stuck it on our data center, our AWS cloud, and our Azure cloud. Same firewall, same configuration, same function, same rules almost. The only thing that changes is the subnet. Now we've got consistent security. So by not using the cloud provider services, we're great. And that's what we're trying to do. We're talking about vendor interoperable. So if you took a load balancer and front-ended to Palo Alto, Cisco, or Checkpoint firewalls, you can use the same policy in any data center, anywhere, or any cloud, anytime. So I wanted to keep that. So I don't have a lot of time, so I can't answer a ton of questions, but I can probably answer about 5 to 10 minutes of questions if you guys have any questions. So if there's any questions for about 5 minutes, great. Otherwise, I can't get to all of them because I've got about 5 minutes or so before I have to go speak to the next set of people. So if anybody has 1 or 2 questions, I can answer it, but I'm only good for about 5 minutes till about 4:45. So actually, in light of that, let's talk about 3 great things that we have for you. So please download. You're absolutely completely free AWS Certified Solution Architect Professional book. This is not a regular book. This is a book that's been built by me and about 35 to 40 people in my team. It's got hundreds of years of experience going in there. The database sections are what do you call it? The database sections are written by database architects. The network sections are written by network architects. This is a real big book. And you can order it now, and it'll be released very, very soon, and it'll be emailed to you as soon as it's done, and it's completely free. Tomorrow, we're going to have our How to Get Your First Cloud Architect Job webinar, and we will tell you, what hiring managers want, what needs to be on your resume, how to get hired, how to interview, and everything that's necessary going to help you build and launch your cloud architect career. And on January 4th, we are going to have a completely live and free AWS Certified Solution Architect Bootcamp. The links are in the description below, and my COO, Chris, is going to be popping it in there. Now, one last thing. In the end of January, because the cloud is a virtual network and a virtualized data center, and in the light of all these cloud outages, and they seem to be happening day after day after day, we're going to run some free networking training for you. And in that networking training, we're going to hammer these networking concepts hard. We're going to talk about building high availability, high redundancy, teach you how the network works. The cloud is a network and a data center that's been virtualized, and nothing more than that. So we're going to teach you the network, the most critical part of the cloud. People like me from the networking background have always worked on the cloud. Now you can too. So I want to make sure we get you guys cloud hired. Abigail Marks, good to see you. Derek Houston, absolutely best of our breed. Abigail Marks, thank you so much. I see Millicent's here. I see Banji's here. I see Perez the Dev is here. I see Pierre. Oh, Shang-Chi, it's so great to see you. Yes. Somebody's saying they're trying to reach us. If you're trying to reach us, have you called our office number at +1 973 896 4889. Our phone number is published on our website, and people answer our phone constantly. So the only way to reach us is to send us an email at elitetechcareers@gmail.com, and somebody always responds, or send us a message on LinkedIn or WhatsApp, or give us a call, and we will call you back, because we return all calls 24 hours a day. In fact, it drives our families nuts, because all of us are returning calls at 10 o'clock at night, which is a little crazy sometimes. The executives take turns passing the phone around to make sure that when people call, so we have no calls from you, sir. Not a single missed call from you today. Although we did have a missed call 36 minutes ago while we were on this session, but we've had no missed calls today. Every call that we've had, someone from my team has called back. So we put the phone number there, call that number, and if you call it now, someone will get back to you tonight. Because we'd love to speak with you. So for any of the reviews that are here, we're going to sign off. Type #CloudHired. Let's get you all cloud hired. Come join me tomorrow, and we'll take care and talk to you for then. Take care, everybody.